So today we're going to cover section 4 of chapter 12, and it's going to be covering the probability of disjoint and overlapping events. So these are all examples of compound events. So when you consider all the outcomes of two events, A and B, we can either see them as a union of the two sets or the two events, or the intersection. And this would be called a compound event. The union would be to list all of the outcomes for events A and B together, list everything. For the intersection, it would be only the outcomes that are shared by both event A and B, so what they have in common. Overlapping events are sort of like an intersection. It's going to be events that have one or more outcome in common. And then disjoint or mutually exclusive events are going to be events that have no outcomes in common. And that's that third picture there. These would be an example of disjoint or mutually exclusive. When we talk about the union of two sets, we're just talking about everything in the picture. Intersection would only be the red section of these two circles. These sort of look like Venn diagrams. All right, so let's talk about the formula for probability of compound events. So the probability of compound events, if these are overlapping, so if A and B are any two events, then the probability of A or B is going to be the probability of A plus the probability of B minus the overlap, what's in common. And then if they're disjoint and they don't have anything in common, then you just take their two simple probabilities and add them. So let's go ahead and take a look at our examples. So we're rolling a dice or a number cube. It wants to find each probability. So here we're going to have two different outcomes that we're looking to get, or two different events. So the probability that the number rolled is less than 3 or greater than 5. So let's go ahead and identify. So what's going to be identified as event A is going to be the number is less than 3. So A will be the number is less than a 3. Event B, it's not showing up. Event B is going to be the number is greater than 5. So what I'm trying to find here is the probability of A or, notice in the description here, A or B. Now let's take a look at what we've got here. Let's list the numbers that are in event A, or the outcomes from event A. So numbers that are less than 3 on my number cube, those are going to be the numbers 1 and 2. Then the numbers that are greater than 5 for event B, that's going to be a 6. So now to find, notice when I listed the outcomes for event A and event B, notice none of the outcomes are in common. These two events are disjoint. Okay, there is nothing in common. They're mutually exclusive. So when that occurs, all we're going to do is the probability of A plus the probability of B. So for event A, the probability of event A, there are two numbers that are less than 3 out of the 6. So the probability of A is 2 over 6. The probability of event B occurring, a number greater than 5, that is going to be 1 out of the 6. And now I add those two simple probabilities. Notice I didn't reduce that first probability, because if I would have reduced the 2 6 to 1/3, I would have to go back and find a common denominator. So I just left it with that 6 denominator, and now I'm going to simplify. So 3 over 6, this will simplify to 1/2. So the probability of a number rolled being less than 3 or greater than 5 is going to be 1/2, or 0.50, or 50%. Let's try the next one. Probability of rolling a number greater than 4 or the number being even. So event A is going to be greater than 4. And those numbers on the dice are going to be the numbers 5 and 6. And then event B is going to be an even number. And the even numbers on the dice are going to be 2, 4, and 6. Notice in my list of outcomes, they have a number in common. So this is going to be overlapping events. So the 6 is what's in common. So when I go to do probability of A or B, the formula I'm going to be using is going to be the probability of A plus the probability of event B minus the probability of both together, of A and B. So the probability of event A happening, rolling the dice and getting a number greater than 4 is going to be 2 over 6. The probability of rolling an even number, there are 3 even numbers out of the 6. And now the amount that you're going to subtract is both of them together. So a number that's greater than 4 and also even. And there's only one of those, so we would subtract 1 over 6. And now I'll add the 2 numerators and then subtract the last one. So 2 plus 3 is 5, minus 1 is 4 over 6, which reduces to 2/3. Written as a decimal, it's actually 0.6 repeating, or 66 2/3%. So if they say round to the hundreds, you could put it as 0.67. Generally, they'll turn 2/3 into 66 2/3. Sometimes you might see it as this, but generally 2/3 will be written as 66 2/3. A lot of these we're probably going to just leave them as fractions. Now, I know we already did probability questions with a deck of cards, but here is an explanation of what a deck of cards looks like. There are 4 suits: clubs, spades, hearts, and diamonds. The face cards are the jack, queen, and king. And then there's 13 other cards, and all of these are in each suit. So there's an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then again the jack, queen, king. So let's go ahead, and the next slide is all going to be asking us questions about a normal deck of cards. So all of these, A, B, C, and D, are all asking us to find the probability of A or B. So notice they all have an or in here. So what we need to figure out is, are these events overlapping or are they disjoint? So let's go ahead and take a look at the first one. It wants us to figure out the probability of selecting a 5 or a face card. So notice a 5 is something totally different than a face card. It could have the same suit, but nothing's going to overlap here. So this would be an example of a disjoint events. So we could say that event A is going to be selecting the 5. And we could say that event B is going to be the face card. Let me do this in black so it shows up. All right, so what we're doing is the probability of A or B. And because they're disjoint, we're just going to do the simple probabilities. So the probability of pulling a 5 plus the probability of selecting a face card. So in my deck of cards, there are 4 5s. You've got a 5 of clubs, 5 of spades, 5 of diamonds, and 5 of hearts. So out of the 52 cards, 4 of them are 5s. And then for the face cards, Jack, Queen, King, we've got a Jack, Queen, King of spades, diamonds, clubs, and hearts. So there are a total of 12 face cards from all 4 suits. Because these are disjoint, I can't get a 5 and a face card on the same card. I'm just going to add these two. I get 16 over 52. I can reduce this by dividing them both by 4, and this will simplify to 4 over 13. I can make it a decimal and a percent. As a decimal, it's going to become 0.308 or 30.8%. Next, we're going to do a face card or a diamond. So again, my face card, this will be event A. The diamond could be event B. This one is overlapping. I can get a face card that's a diamond. I can get a jack of diamonds, a queen of diamonds, and a king of diamonds. So for this one, since it's overlapping, this equation is going to be the probability of A or B is going to be the simple probability of A plus the simple probability of B minus the overlap. So A and B together. So the probability of pulling a face card, again, there are 12 face cards in the deck, so 12 over 52. The probability of getting a diamond, event B, there are 13 diamonds in the deck. And now the overlap. So the face cards that are also a diamond. So again, king of diamonds, queen of diamonds, jack of diamonds, there are 3 of them. So I'm going to subtract out 3 over 52. So I'm going to add 12 plus 13, I get 25, minus 3 is 22 over 52. I can divide that both by 2 and reduce this to 11 over 26. I can also make this a decimal by dividing it, and as a decimal, 0.423 or 42.3%. The next one wants me to select an ace or a 9. I can't get an ace and a 9 at the same time, so this would be an example of 2 mutually exclusive or disjoint events. So for this one, when I go to do it, again, I can classify event A as getting the ace and event B as getting the 9. So again, I'm doing probability of A or B because that's what's written in the problem. And again, when they have nothing in common, I just do the 2 simple probabilities. So probability of A plus the probability of B. So probability of getting an ace out of the deck of cards. There are 4 aces in my deck. And there are also 4 9s. I will add those numerators. I can divide 8 and 52 by 4, and this will reduce to 2 over 13. I can divide that, make it a decimal, and it becomes 1.54 or 15.4%. Yes?
What is the factor that having the or have to do with anything?
Okay, so yesterday when we did the other homework, it had probability of A and B happening at the same time, and that's when we multiplied the percents. So you just need to make sure you pay attention to those conjunctions, if it's an and or an or. because it'll change the formula you use. All right, so let's try the last one here. A 10 or a diamond. I can get a 10 and a diamond at the same time. I can get the 10 of diamonds. So this one would be an overlapping event. So again, we're going to do the probability of A or B, because again, the word or is in the problem. If they said find the probability of a 10 and a diamond, that would be a different question. So again, we would do probability of A plus probability of event B minus both together. So again, this could be event A getting the 10 and event B could be getting the diamond. So probability of getting a 10, there are 4 10s in the deck, so 4 over 52. Diamonds, there's 13 of them, but then there's only 1 10 of diamonds, so 1 over 52. Add 4 plus 13 and get 17, and then subtract 1 and it's 16. I can reduce this, divide both of them by 4, and again, make it into a decimal, which is 0.308 or 30.8%. So if it asks you to, let's say they change the question, and let's say the question just said, what's the probability of selecting a 10 and a diamond? Then that would just be 1 over 52. And again, that's where you have to write out the sample space. So again, watch the words. Let's try one more example, and we're done with the notes. It's a word problem. So here it said, of 100 students surveyed, 92 own either a car or a computer. So they own either one. Also, 65 own cars, 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So this is where we're using the probability of A and B, not A or B. So what we're really finding here is probability of A and B. So event A is going to be that the student owns a car. Event B is the student owns a computer. And then notice they also gave me 92 own either a car or a computer. So I can also now write down that one. So I'm going to be doing the simple probability of owning a car. And we were told that 65 own a car. So 65 out of 100 is that probability. Probability of B, there are 82 that own computers. And again, they also gave me the probability of A or B, and that was 92 over 100. Now, the formula that we've been using when it was overlapping, remember, was the probability of A or B equaled the probability of A plus the probability of B minus the probability of A and B. This is what we're solving for. This is what we wanted, that a randomly selected student owns both a car and a computer. So what I'm going to do here is I'm going to solve for A and B. So let me try to get that probability all by itself. So what I could do here is I could move this to the other side. Let me fill in my numbers first. So I know probability of A or B is going to be 92 over 100. probability of A is 65 over 100. Probability of event B, 82 over 100. And I don't know this probability. This is what I'm solving for. So what I'm going to do is try to get this all by itself. So let me go ahead and just move this to the other side. So I'm going to add this. Probability of A and B. If you'd rather write this in as a variable, so you don't have to write so many letters, you can. So I have the probability of A and B plus 92 over 100 equals 65 over 100 plus 82 over 100. I can go ahead and add these two together, or I could just move this over and then do it all at once. So the probability of a student owning a car and a computer is going to be found by doing 65 over 100 plus 82 over 100 minus 92 over 100. And that total is going to be 55 over 100 Now, if they expect you to simplify it, you can reduce this to 11 over 20. We can make it a percent, 55%, or as a decimal, 0.55. So 55% of the students own both a computer and a car. So 55% of the students own both a car and a computer. So your homework is the odds. I'm going to go ahead and get the evens posted as well. That will be tomorrow night's homework. I did fix the file. I ended up putting them in as a screenshot, so hopefully they'll open up in Notability better now. Any questions? Anybody need me to go back to anything?